Hello? Hello,
Hello,
hello?
hello, hello.
Hello, hello, hello.
Hello, hello, hello. Wait, let me refresh my. Are we back again
Yes.
with another stream?
Yes, we are.
Yes, we are. We're back with another stream with 3 people now. Not 2. 3
There's
people.
3 of us.
There's 3 of us. Damn. Oh wait, let me mute myself on my stream here. Damn, we got some exciting news today. Some excited stuff. We're excited. Excited business we're doing today. You know. Do you mind, Carlos, telling the audience who we have right now?
Yeah.
Second time.
Let me just
Second
while
time
I'm
up.
doing that, listen to the audio. I want to make sure we're good. Everyone, we got a guest today, special guest, close friend guest, Michael.
Close friend.
Michael, he goes to school with us. He is leaking our school on his shirt right now, but that's
Oh.
okay. That's okay. I mean, people
Just look at this part.
people can figure it out on LinkedIn. Not a big deal. But
Yep.
the main premise behind today's stream is he's practicing for some assessments coming up, and
Yep.
we basically reached out to him. Hey man, we heard you got some assessments coming up. Let us help you. Let us coach you, if you will, guide you, get you familiar with some stuff. And he accepted, so that's one of the reasons we're here today, doing one of our first coaching streams.
Yeah.
So, we've
Coaching
done this-
Audio
number
sounds
one.
good.
Audio sounds good?
Audio sounds
Okay.
good.
We've done this before with Mike. You can find it in one of our videos, but this time it's serious. You know, Mike's been studying hard, Mike's been practicing, been learning, and he wants to take it to the next level. So we don't claim to be experts here. Me and Jose don't claim to be experts, but if you look in our channel, we have a lot of experience with LeetCode, and at least with the easy problems, and think we give them some advice and best ways to tackle these online assessments. So without further ado, I think we're ready to start the first portion of our stream. First portion of our stream will be pattern recognition by reading the LeetCode problems. So let me get this open. Let's see. Let's switch screens. Okay.
Let's do it.
Audio sounds good, Jose?
Audio sounds good, brother.
Okay.
Audio sounds good.
Perfect. So what we're gonna do now is I have so many screens open on my, so many tabs open on my screens. Crazy. Me and Jose chose some problems for Mike to read out, and all he has to do is just tell us what algorithm or what approach is the problem looking for, a general approach. And he might not know it, he might know it, but that's what we're here for. We're here to help him. Like, this is practice. Like, you're not going to be an expert in practice. Like, whenever you're practicing math problems, you don't know the math, you don't know it all the time, right? So failure is good here. We're open to failure. We're open to learning from our mistakes. So we encourage that in our lives, in our daily lives and stuff like that. So anyways, I'm gonna get the first problem for you, Mike, okay?
Yes, sir. Let's do it.
You understand what the assignment is?
I do understand. Hopefully, I can get either all of them or most of them.
All right.
But we'll see. See how it goes.
I
See what y'all
wonder-
throw at me.
I wonder if this
Jose is
works.
asking how much for a coaching session.
Who's Jose?
Oh, no, somebody in the
Oh,
chat.
someone in the chat. Jose says, how much for a coaching session? Free 99.
I know. $3.99.
$3.99.
Yeah. I would say free 99.
Okay.
Dude, I'm a little nervous. Is the audio working or no?
Yeah, the
Triple-
audio's working. I'm gonna double
Okay.
check.
Yeah, triple check.
I'll double check.
Triple check it. Triple check it.
Yeah,
you're
you
doing
guys can
that-
start. I'll jump in.
While you're doing that, I'm going to. Oh. While you're doing that, I'm going to switch the tab. Alright. Okay.
Audio sounds good. Audio
Audio
sounds
sounds
good.
good? Okay. And alright, first problem. Are we ready? Everyone's good?
I think so.
Mhm.
Okay. I'm gonna move that. I'm gonna move that.
I had to watch your stream.
I'm
That's
gonna
okay.
move this. And then okay. So, Mike, first problem. Don't worry. Don't. Does it say the answer anywhere? No, right?
I don't see it. No.
Okay, good. All right, Mike. We made it easier for you. It's a multiple choice. Multiple choice, okay? Read this problem and tell us whether it's a two-pointer approach, sliding window approach, binary search approach, or a hash map approach, okay? Go ahead, Mike.
Okay, threesome. Given an integer array nums, return all the triplets nums I, nums j, nums k, such that I does not equal j, I does not equal k, and j does not equal k. And nums I plus nums j plus nums k equal to 0.
Keep going.
Notice that the solution set must not contain duplicate triplets. Okay. Example 1. Input nums equals the array -1, 0, 1, 2, -1, -4. The output's going to be -1, -1, 2, and -1, 0, 1. Okay. Explanation. Nums 0, nums 1, nums 2 equals -1 plus 0 plus 1 equals 0. Let's see, 0, 1, 2, yeah, equals 0. Nums 1, nums 2, nums 4, which is 0, 1, and -1, also equals 0. Nums 0, nums 3, nums 4, -1 plus 2 minus 1 equals 0. The distinct triplets are -1, 0, 1, and -1, -1, 2. Notice that the order of the output and the order of the triplets doesn't matter. Example 2, the nums 0, 1, 1 output is empty. Only possible triplet does not sum up to 0. That makes sense. Num 0, 0, 0. Oh.
You didn't see the
what
approach
happened?
at the bottom, right?
No, I didn't see it.
Okay, close your eyes. Hold on.
I was
Let me
doing
cover
good
it.
at example 3.
Close your
I
eyes.
didn't see it, I didn't see it.
Damn.
Close your eyes. Let me cover it up real quick.
Oh, okay, good.
Close them. Boop. Okay, you're good. Sorry.
Okay.
Go.
Example 3. Nums equals 0, 0, 0. Output is 0, 0, 0. The only possible triplet sums up to 0. Cool.
Whew.
There it is.
All right, Mike. What are you thinking? What's going on in your head? Don't get scared at the medium tag right here. Okay. Jose, you got something
Yeah,
to
but
say?
it makes me a little nervous.
Can
I
you
don't
write
know.
down the options on the on the right? That way Mike can have them
Options.
visually.
Yes.
Yeah.
Options number 1, Mike. 2 pointers. Okay. Oh, let me do this. Okay. Number 2, Mike, is sliding window. Okay. Number 3 is binary search. Number 4 is hash map.
Okay.
Those are your options. Please feel free to ask questions. This is the first problem. You know, it's okay.
Yeah.
It's okay if you don't know. That's not a problem at all. Just tell us what you're thinking though. What's going through your head? You know, what do you? I don't know.
Well, can I don't think it would be binary search. First off,
Why?
Okay.
strike that one out. I guess I don't really have like a super good reason. Like I feel like for binary searches, it's more so about like balancing things out and then sorting. So it's like this doesn't really need a binary search because it's just like It's just like looping through an array and then seeing what you need from that array. So I don't think it needs binary search.
Okay. I'm gonna just put an X right by it.
Okay. What is sliding window? Can I ask that?
Yeah, go ahead,
I don't know what
Jose.
sliding window is. Okay, what's
Okay.
sliding window?
So sliding window, you got like 2 pointers. Let's call it I and J,
Oh.
and the space between, or the element in between I and J, that's your window. That's the only element, and that's the only data or information that you can work with. And then let's say you wanna, then you slide those I and J into another window. So I plus 1, J plus 1, and then you got another window. Then I plus 1, J plus 1, you move into another window. So it's just like, it's a window of elements that you see and that you work with, but you just slide it across an array, hash map, whatever it is, but you just see certain elements based on those 2 indices.
Okay, so you're like checking parts at a time. What it's
Mhm.
doing. Okay. Mhm. I think sliding window might be able to work for this or that, just because like you are adding up the indices to make it 0. It might be a certain approach.
Okay.
But I think the one that I would use, or that I've used before, for twosome, would be a hash map. Is what I would go with.
Why would you choose that? Are you only choosing that because twosome was hash map?
I mean, maybe, but also like I feel like hash map also would work here because you're still going to be creating like key value pairs, right?
Mm-hmm.
So like even though we use it for twosome, I feel like it could still apply here.
Okay. Let me see. Let me verify that. Let me verify that. We have fact check on that.
Cause like you're still grabbing an indice and a value like together.
Yeah.
So even though we're adding another like a third variable to it, I feel like we could still use hash map for it.
Okay. Okay.
I mean, I'm sure. I'm not doubting that. I'm not doubting that. Wait, Jose. I'm gonna let Jose speak because he's looking at it.
No. You keep on going. Keep on. I'm still doing a little bit of verifying over here.
Well, he chose that as his answer, so we gotta tell him if he's right or wrong.
Okay. You want me to do it?
Yes. Go ahead.
Yeah. Okay. So your answer, Mike. It is wrong.
No.
It is wrong. The right answer is 2 pointers.
Oh.
So the reason why, to my understanding, because I haven't done twosome in a while, so that's why I'm verifying here.
I wonder if we did two.
You want me to close my eyes? You want me to
No,
close my
I
eyes
mean I
again?
think it's already good now. Oh, what the?
Okay.
What the?
No, I think we did a whole
C.
different thing.
This is C.
That's C. For some reason. Oh, remember that time we did the blindfold?
Uh huh.
The blindfold
No, but
challenge?
this is-
Blindfold. You want a blindfold?
Dude, we didn't even solve
Yeah.
it.
Oh, boss, bro.
No. But yeah, I did. I think I have my. For some reason, I have solved it on my own account.
Okay. Okay.
Over
Perfect.
here?
Perfect.
So,
you
the
mind
reason.
sharing
Let
that
me see.
code?
Let me verify that. Yeah. Let me see. Let me see. Oh, there you go. Just shared it.
Okay.
So we got the dictionary, the answer, blah blah blah. So we do the range for not I in dictionary. We're gonna get the I equals 0, 1. Okay. Target at position I. cur, if cur in dictionary cur. Okay, so mm, I know why we did a dictionary. I think I understand why, but I'm not really sure. But well, the reason why it's a two-pointer is because do you know how a two-pointer works?
How does it work?
So two pointers is similar to sliding window, but in sliding window, those two I and J stay static. When one moves, the other one moves, right?
Yeah.
Keeping that window. Two pointers, you work with with two indices, but they move within each other. So you, like in this case, right? Here your two-pointer approach is line 14, where you have L and R, which is your left and right, and then you move the R and left on lines 18 and 20. So based on your current sum that you have, you're gonna move your right or left. That's the two-pointer approach, because you have two pointers that you can use to get information, right? So that's why it's a little bit more. It's better to do it this way, because that way, because you're working with three values now, not just two. So a dictionary will work perfectly with two values. But with three values, you need to take into consideration three elements of the array. So you have to figure out a way where you can access the three elements at the same time, figure it out if they're equal to 0. So that's what the two-pointer is. As the third element, right, comes from I. I is the value that we're looking right now. Left and right are looking for the other two elements that equal to 0, if that makes sense. Yeah, so that's why sliding window is good here, because you need three variables and or three elements at the same time, and you still have to figure out all the possible combinations that give you 0. So that sliding window gives that two-pointer gives you the ability to find those extra two elements.
Gotcha. Okay.
Yes.
All right, Mike, that was a medium problem. We'll give it to you, okay?
Okay.
Let's go to the next one. I think the next one's a little bit easier. So pardon that right there. Let's see. Oh, no, it's not. Oh, okay. Actually, no, but this is good. This is better though. All right, Mike,
Okay.
close your eyes real quick. I think I need to cover something.
Okay.
Boop. Okay, Mike. It's medium again, Mike. But I think it's a little bit more self-explanatory than the other one. Okay, can you see it? Can you see?
Yep, I can see.
Okay, Mike, just read it. You don't have to read everything. Just read the question. Don't worry about the examples. If you want to read one example, read one example. But you don't have to read everything. Go ahead.
Okay, I think I actually got this on a past OA before.
Okay,
So,
did you end up
Should be.
figuring out why?
No, not at all. Not at all.
All right. Well, here's your chance.
So yeah, this should be pretty interesting figuring out. Longest substring without repeating characters. Given a string S, find the length of the longest substring without duplicate characters. Okay. Example 1, input S equals ABC, ABC, BB. Output is 3. The reason why is the answer is ABC with the length of 3. Note that BCA and CAB are also correct answers. Answer is B. Output 1, answer is B with the length of 1. Okay. Got it.
All right, Mike, what's going through your head now? Remember, everyone that's watching, the goal right now is for Mike to be able to read problems and just get a general understanding of what approach will he take for that problem. So it's like pattern recognition, right? So tell us what you're thinking.
Wow.
Let us fill in those gaps. Let us know. What do you think?
And it's the same choices?
Same choices, yeah.
Same choices. Okay. Hmm. So sliding window slides, but it's
Yeah, what-
fixed. The pointers that are on it are fixed, right? You said.
Um.
Yes, like fixed
Yeah,
as
you
in
would say
they're
so.
Yeah, it's like
they're the same length, right?
Yeah.
Yeah.
Okay.
Well,
Okay,
there's various types of sliding window algorithms actually. There's two. There's a fixed length and there's a variable length.
Hmm.
But the goal is like it's a window, and you're gonna slide with it. And then the other one is you're gonna expand or you're gonna close the window.
I forgot to say that. Yeah.
Okay. Can I just binary search? Is it typical to use with string manipulation?
Not that I know of.
Okay, let's. Just
I don't
remove
think
that
it's common. I don't think it's common.
one. I was gonna remove that one off the back.
Okay,
'cause I
removing
feel like
binary
I'm-
search. Okay.
Okay.
Well, what's the goal here, Mike? What's the goal of the problem?
We need to see what the longest length of the substring is without having a duplicate character.
Mhm.
So, like, we can't have BB or AA. I mean, we can have those, but like if there's a longer string of characters or like a longer substring of characters, like the output is gonna produce like that longer one versus the shorter one. I just don't know. The only thing is that, let me see. So, can you explain two-pointer again?
So two-pointer, you pretty much you have two indices, I and j, and you work with those two indices. So you work with the element at position I, you work with the element at position j, right? And based on a condition or whatever, you move those indices, like either closer to each other, one far away, all that. But you work with the indices you work with the elements in those indices specifically.
And also, usually with two pointers, you start the pointer in the beginning of the list. You usually do two pointers for list, like list questions. So you start a pointer in the beginning and then one at the end. That's like, but also there's other algorithms where you use like two pointers. I don't know. Would you consider the linked list, the hare, and the turtle a two-pointer approach, Jose?
Yeah,
Technically,
I would say so.
In that case, that's like a linked list type of algorithm. You like start the pointers in the beginning, but you see those only for like linked list questions, not necessarily list questions.
Okay.
So right now, like unless you see like it mentioned linked list, that's when you start thinking of those algorithms. But I don't see anything about linked list here. You have a string, right? And with a string, you can break it up into an array, right? So that kind of give you a couple of suggestions on what approach it would be, right? So it is tricky, but I think the wording, once you get familiar with the wording and stuff, you would associate this algorithm immediately with what the problem is and the name.
Think of it about this way. I'm gonna give you a tip. Right? I'm gonna explain a sliding window. Sliding window, you have two pointers, right? But you work with the data in between those two pointers. So you can have one pointer at one position and expand the other pointer and work with the data that's inside those pointers.
And I think with
like,
two,
the length of the sliding window though, like, is there a certain length it can be?
Like Cardo said, there's two. One that is static, right? that has a specific like static length, and the other one can be dynamic, where you can
Expand
move
it.
one of the or
You can
expand it.
expand it or you can shrink
Yeah.
it, depending on what the
Yeah.
problem's saying. Usually the fixed length one is saying like the problem's saying like within a 5 character range, find the highest sum within that range, right? So if you have a list of numbers and it's saying within a 5 element range, right? Like let me show you real quick. So you have like 5, 2, 3, 4, 9, 16, blah blah blah, right? Within a 5 range, 1, 2, 3, 4, 5. So the beginning of the sliding window will be here, and then the end will be here. You shift it over. You shift over those two, and then now it'll be 1 and 7, and the next one will be 3 and 8. Does that make sense? That's a fixed window.
Yeah.
Like you're sliding the window over. Does that make sense?
Makes sense.
Right? A variable is one where like you start the 2 pointers here and then you expand the end. So you go from 5, the beginning is 5, the end is 1. You expand it to where the end is now 3. Now the window is a size 3. And you expand it again, now the window is a size 4. But then you can also move it, so now the beginning is 1 and then the end is 16. Is that making sense or no?
Okay. Yeah.
Okay, so that's the two like various types of sliding windows, but it all depends on the problem. So with that being said, it wants to find...
one more minute.
One more minute?
One more minute.
Gee,
Who was?
Come on, brother. We gotta put you that pressure.
It wants to find what?
It wants to find the longest substring without repeating characters.
I'm kidding, man. You have all the time you got.
And another thing,
you're
Mike,
good.
another hint is that 2-pointer approaches, if I'm not mistaken, those usually involve like calculating numbers. Am I wrong,
Okay.
Jose?
The 2-pointer?
A 2-pointer approach, like you're usually doing that to add stuff up. Like, I mean, of course, there's special cases, but the 2-pointer
Yeah,
approach
I mean-
when it comes to lists, like you're looking at the values of the
I
left
think
pointer
that's
and the right pointer.
Yeah,
and you're comparing
that's-
which one to move inside, which one to move like.
yeah. That's the main difference between sliding window and 2-pointers. 2-pointers you work like you said with the values at those indices. Sliding window you work with the data inside those indices.
The window, yeah.
Inside the window, yeah.
Okay.
All right,
I
man.
think maybe you can probably do sliding window or hash map.
Okay.
But I
Why-
feel like I think. Huh?
Why are you thinking sliding window or hash map? Give an explanation.
Sliding window makes sense. I feel like because like if you have that window and you're checking like the letters inside of it,
Mm-hmm.
like if you have like when you write out the code and like you have that little window, inside that window it'll kind of scan those characters
Mhm.
and see like what that longest substring is, right? And it'll like kind of like record that or save that, and then it'll move the window over to like the next stuff.
And the hash map.
And
You
then
know what?
like
Yeah, you know what? I'm being nitpicky right now. Mike, you got it right, Mike. Sliding window.
okay,
Congrats.
nice, okay.
I'm gonna hit the yay. Let's go. Clap it up for Mike.
Yay?
Right
Can
here.
you explain it like?
Yeah, can we get a
Right.
scale draw and we'll explain it real quick to you.
Yeah.
Then
I
open
sent you
scale
guys
draw
a
real
link.
quick.
Yeah, I have it up. Let me see.
Let me see.
Could it also be hash map?
It could be. You have to would really have to work it out, like the logic
Okay.
behind the hash map
Gotcha,
and
gotcha,
stuff.
gotcha.
Yeah. But you could use a
All right.
Scattertron.
Let's explain it using that example that's on the LeetCode. Oh, let me get it. Should I get it out? So real quick for you, Mike. Boom. So we have this. Okay.
Yes.
Sliding window. I'm going to add. Basically, the problem is saying. The problem's saying, what's the longest substring? What's the longest substring within the string that doesn't have repeating characters? The reason why you don't use 2 pointers is because you usually start a pointer right here. Okay, enough with the doodles, Mr. Picasso.
I'll say.
All right. You usually have a pointer
Hey, I'm
starting.
showing. I'm giving him a preview. I'm giving him a preview.
You usually have a pointer starting from here and the end, and your goal is to bring them in closer. That's the 2-pointer approach. You bring them in closer, right? Now, Mike, you tell me, is this finding the longest substring?
No.
No. I don't think that's the best way. You got to start from the beginning, and you got to expand. Okay, A, B,
Yeah.
are those the same? No. A, B, C, are those the same?
Move on to the
Is
next
there a
one, yeah.
repeating? No. Is this one A, B, C, A? Is there a repeating now?
Mhm.
Yes. So now you know your longest length is 3. Okay.
Yeah.
Now you shift over. Boom.
Yeah. That's what I was thinking.
You shift
what I
over,
was thinking.
and then is it repeating? No. You expand. Is it repeating? Yes. Okay. Your longest is 3, and then you keep going. Does that make sense?
Yeah.
So that's the sliding window. That's the variable sliding window, because you're expanding and you're also shifting, shifting them. And
Yeah,
that's
that's what I
how.
was thinking too, cause like I was like, it's gonna check these first, or like whatever like you give it,
Mhm.
and then okay, or like, I'll check those first, like you said. This isn't one. This isn't one.
Mhm.
This is one, right? So then it checks that, and then it saves this somewhere as like the longest, right?
Mhm.
So right now it's 4, and then it'll shift this, and then check that, right? Will it stay that length, or will it reset to like 2? And
It
it'll,
will
like, check
stay
it.
the
Well,
length of the last, like not like a non-duplicate,
Yeah,
like right here. If it
That
goes
makes-
all the way to C,
that makes sense.
right, the length is 3, right?
Mm-hmm.
If it goes to A, then obviously there's a duplicate. You go back, so the length stays 3, because that's the last like longest length.
Yeah.
Make sense?
So so it checks this. This is a duplicate, so it goes back to this.
Mhm. Mhm.
And then since 3 is the longest substring right now, it's the window doesn't have to reset itself.
exactly.
Right? 'Cause we know it's 3.
Mhm. It never
So
goes
then it's
shorter
gonna-
from there,
Check that.
because
Yeah,
you want
okay.
the longest substring.
That makes
Make
sense.
sense?
That makes sense. That makes sense.
And then
Third-
lastly, just for future reference, a fixed window is whenever they tell you, okay, within a 3 length window or range, what's the these are using letters, but imagine they're numbers. What's the largest sum you could find in a 3 range window? So basically,
Okay.
you have it fixed, like it's gonna be here forever. It's gonna be the length of 3 forever, but you keep shifting over and you calculate the sum of all 3 until you find the largest. Make sense?
Okay.
Perfect. All right, let's go to the next one. Jose's doing doodles and stuff.
You're going crazy.
Dude, no. I'm paying attention. I'm letting
I'm
you
going
coach
crazy.
him.
Oh
I'm
shoot!
letting
Oh
him coach
shoot!
him.
Close your eyes, Mike.
Oh.
Yeah.
Close your eyes, close your eyes.
Yeah.
Okay.
All
I
right.
think you should be good. All right, let's see. Anyone chatting?
I think you got this, Mike. I think you got this, bro.
Any
I
chatter?
think you're gonna get it like in a minute.
This new one.
Yes, sir.
Let's see it. Let's see it.
just
Let's see it.
verify something. Okay.
And we got 3 viewers right now. Please come in the chat. You
Please
know,
like,
say a little
subscribe.
hi or hey, something
Yeah,
like
say
that.
something.
That
Say
way we
hello.
can give you a
Say,
shout out.
or maybe some advice to Mike or whatever you need. Whatever y'all
Mhm.
want to say.
Mm-hmm.
Next thing is just to remind everyone what we're doing right now. We're helping our buddy Mike prepare for an online assessment. He's been practicing. We asked him, hey, let us help you. Let us get you some extra practice, and that's all this is right here. So we're not claiming to be experts, but we think offer some little advice that might be valuable to Mike before he takes his assessment. So we are doing pattern recognition right now, but the next one will be actual problem solving. Okay, so this will be the last one for Mike. And you're given, let me go get these real quick. You're given the multiple choice options of these.
Fast.
All right,
You got this, Mike.
Mike, go ahead and start
Okay.
this next one. Read the problem. Let us know what you're thinking. Talk out loud. Okay, that's very
right.
good. Go.
Search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. If not, return the index where it would be if it were inserted in order. Okay. Example 1. Nums is 1, 3, 5, 6. Target is 5. The output's 2, which is the index. Again, example 2. 1, 3, 5, 6. Target is 2. Okay, output 1. That makes sense. Nums 1, 3, 5, 6. Target is 7. That would be 4. Okay. Sounds good. I got it. The output.
Got it?
The output is gonna be the indice in which that number belongs in order. Okay. Okay. All right. Can I just rip it? Can I just rip off the?
Yeah,
No,
yeah.
No,
I'm
no.
gonna give an answer.
No.
Yes.
You
Give me
gotta-
an answer, bro.
you gotta-
Give me an answer.
You gotta
No.
cross them out.
Give me an answer.
Cross out
Okay.
the reasons
It'd be
why
crazy-
those choices are not.
Give an answer and then say your reason why you chose that answer.
No, you gotta go
Yeah.
down the
Thank you.
steps.
We gotta comment turn into Alexa. Thank you, Alexa.
Oh,
I appreciate
wait.
I appreciate the
Oh.
Good luck,
Hey,
Mike.
thank you, Alexa.
Oh,
Thank you,
thank you, Alexa. Appreciate it.
that.
Appreciate it.
Thank you.
Mike, you got some good luck, okay?
Got good luck.
Use it right now, bro.
All right.
You can rip it. You can
So
rip
no, you can't, Mike.
Carlos said I
it.
can't.
You
rip
can.
it.
Mike,
You can.
You gotta
can,
go
you
down
can.
the list. Go down the list of options and say why it's not that or why it is.
Okay.
Come on now.
Or you
It's
can
not-
say
This
your
isn't a
answer
test,
and
Mike.
Say,
This isn't a multiple
and
choice
say why you
written
got
test
there.
where you could just circle C or whatever you want to do and then just guess. You're not guessing.
Circle
You
C
gotta
if you know why.
Okay. This
Alright.
is not 2-pointer.
Okay. Why do you think?
See, now I'm scared. What if it is 2-pointer?
It's okay, dude. It's
Um,
okay. Failure is okay here. We're here to help you.
But what if?
This guy.
Jose, come on.
Okay. Come on. Let's lock in, Mike. Let's lock in.
Let's see, bro. We need a target. Okay, we have a target. Return the index if found.
What are the key words here? Is there any key words in the problem?
I think I know he got the
Well-
answer.
Return the index. We have an index. And we have... index is a keyword. And I feel like we have the array with the index with the value. Inserted in order.
Oh.
See, now I don't know.
Oh, okay. You.
Rule number 1,
Okay.
not binary search.
Okay. No binary search. Do you confirm?
Yeah, I'll confirm now. This doesn't
Okay.
look like a... Let's say
Okay.
it doesn't look too binary searchy.
Okay.
Say this one right here.
Come on. Put that X there,
Um,
Carlos.
Boom,
Okay.
with the X.
Oh.
Oh.
X.
Okay.
Hang on, I'm trying to think. Give me a second, bro. Let me
Look.
lock in real quick.
Okay. You already scratched out number 3. Can't use it anymore.
Okay.
I don't think we're that good coaches anymore.
No, I think we are. I think he had it.
Well,
Now I'm scared, bro. Y'all got me
Okay.
all nervous now.
Okay. Yeah. So you were right. We won the index, right? We won the index.
Yes.
And what is it saying when what are we trying to do? We return the index if the target is found.
Yes.
Found. Think about that. Found. Right? Found. What do you need to find something? What do you need to do to find something?
We need to search it.
oh,
Oh.
oh,
Oh. Right in the heart, boys. Right
But
in the heart.
you crashed it out though. You crashed it out.
Oh, fuzz. My heart. It's already out.
all right, Mike.
How would you binary search that though?
What is binary search, Mike?
It's when you get your like array, right? And then you. Oh wait, hang on. I'm trying to think.
In what state does the array have to be in? The array of numbers.
It has to be in 2 separate areas, right?
No, what state does the array of numbers need to be in? Sorted, unsorted.
In
a binary
it has to be
search.
sorted.
Say that again.
Well,
For a
it has to be
binary
sorted.
search algorithm,
I don't know.
it needs to
pretty
be
sure
sorted.
Okay.
Binary search algorithms, in order to
given a
do,
sorted
then
array.
you only could use it in a sorted array.
Okay.
Because binary search is whenever you start in the middle, you compare that value that you found in the middle to the target. If it's less than or great, if it's less than the target, then that means the target is on the right side of the array. Right? Yeah. If it's greater than the target, that means the target's on the that means the target's on the left side of the array. So you start in the middle of the list. Right? If it was unsorted, and in the question it says sorted array.
Yep.
If it's unsorted, and they're distinct integers, they're not the same. So that's the hint there. Another hint.
Sorted array.
Another hint is log n of time.
Yeah.
Log n. That's
Binary search.
the complexity of a binary search.
Okay.
So
And to answer,
go ahead,
Carlos.
Go ahead, Jose.
To answer your question, how we would solve it. So we got 2 things. This problem is asking for 2 things. We have to either find the target, or we have to find the position where the target would be. So for that, we do similar. We go with a similar, like your basic binary search. We check, hey, if you're lower than me, so you gotta go to the left. If you're bigger than me, you go to the right. Boom, 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 boom. Yada 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 yada. But if we didn't find it, meaning that the left and right crossed each other, meaning that we exhausted all possible solutions, right? We go and check on line 25 over here. It says if num's mid, right, is greater than target, that's where mid it would go. That's where you would go, right? But if mid is less than target, you will go 1 position above it. If that makes sense. Because if the target is less, right, you're gonna take that position, and mid is gonna go 1 plus 1. And then if you're lower than target, if mid is lower than target, mid is gonna shift down to make space for the new target value. So that's how you would solve it a little bit.
Okay.
Any questions, Mike, before we move on to the next segment?
I'm just trying to see. Trying to break it down a little bit more. We have the sorted array. We have a target. The binary search implements target if it's 5. So let me see. So the binary search, it splits from the target or from the middle.
And from the middle.
But like there, so it splits to 1, 3, and 5 and 6 then.
1, 3, 5. Yes. It rounds like a line 14. You add both left and right. You get the 2. You get the floor of it. So let's say it's 3. In this case, it's gonna be 1, 2, 3, 4 divided by 3 divided by 2, which is 1. Floor it. So you're gonna start at 3. So you're gonna start index 1. Right there.
Okay, and then that's where you.
Yeah,
do the
and
rest
from
of the
there,
binary.
yeah.
Is
Yeah.
3, and then you say like, is 3 greater than target? No. Is it less than target? Yes. So now mid gets added +1. So if mid's right here, now mid's right here.
Okay. And now you have your target.
And then
so now you have your output.
if mid equals target, then you return mid,
Okay.
which is 0,
Okay,
1, 2.
okay.
So that's just the cool thing here about binary search is the algorithm is something you would have memorized, and you kind of just do the algorithm and then just add finishing touches like right here at the end. Like if there is no location, if you can't find target, then you need to add just a little extra logic to get the problem right. But
Okay.
the key thing you should notice that you have a sorted list. They're all distinct integers. That right there kind of sums down a lot of stuff. And especially when it says like if the target's found, if like anything like that. It's implying like you're searching for something.
Okay.
Got it?
Mhm.
Alright. Now we're gonna switch it up to problem solving.
Switch it up.
Okay.
Okay.
So, good job, Mike. Good job, Mike. Okay. Keep your
yeah.
stay confident. Keep being positive. Okay.
Yes, sir. Yes, sir. Yes, sir.
Let me.
Hey, well, we got 5 people watching. We only got 4 likes. Come on, man.
Oh,
Come on, man.
oh.
Come on, man. Come on.
Let's get those
That's
problems.
that's you, Mike. That's you, Mike.
What?
You didn't give a like.
I liked it. I'm liked up.
Hmm.
It was you,
No,
probably.
man. No, I'm gonna give it a dislike.
Probably.
I'm gonna give it a dislike.
Mike.
That's crazy.
While we're waiting
What?
right now, what do you think you've learned? What are some good things you've learned so far?
I learned what sliding window is. I didn't know what that was. And it seems, I don't know, that I feel like sliding window has like very good use for certain string manipulation questions. Or just, yeah, I think so. I learned how to recognize when to use a binary search a little bit. That's pretty solid. Or just like, you know, the common lingo for binary search, like, you know, if we have like the target and like we're gonna search in the array, and it's sorted. I got that down pretty good. 2-pointer also learned a little bit about 2-pointer. So I'm not like I wouldn't say I'm like super confident in like all of them just yet, but like I at least know how to recognize them a little bit more, which is good. So I'm at right now.
Jose, any questions
It's
for Mike or any advice right now?
No, I mean, as long as you see the little keywords and understand them, I think you should be good, man. Sure.
Yes, sir. Yes, sir. Yes, sir.
Keep the conversation going, boys. I'm looking for these problems.
What?
What
What?
kind of
What-
problems are we gonna be looking at?
What are we looking for?
So, I'm looking for some problems for you, Mike. I think we just need to get your confidence up right now, okay? We're gonna guide you.
Okay.
We want to get your confidence up. We know that that's a big thing when it comes to these things. So let's start off with some ground balls, okay? We're gonna give you some ground balls.
Okay.
And don't look at this.
Oh.
Give you some ground balls, and then we're gonna step it up a little bit, okay?
Yep.
All right, let's get it going. Boom. All right, Mike.
Can you just share the thing with me? I think.
Share the thing with you. Yes. All right. There you go.
Share that thing.
Okay,
Yes.
Mike, and let me fix it up right here. Now, Mike is going to solve problems. Solve problems. Okay. Yeah.
Alright.
We need a moderator, man. This thing is getting hectic. Can't even
What is-
focus.
I can't even talk, bro. I
Can't
can't
even-
even
What?
see.
Can't
Keep up with the
focus.
chat.
No, I mean like so much production stuff. Like, oh, that's so stressful.
You need a producer. Bro.
I'm stressed, man. Can't even
A
focus.
lot of moving parts.
Okay, I'm focused now. Mike, we're back, Mike.
We're
Mike,
back.
now that you got a little bit feet wet, right? We have about 30 minutes or so before we would have to end the stream. But let's throw some ground balls for you, okay? Here is the first problem that we want you to solve. Think out loud, okay? Think out loud. Ask us for help. We're here to help. We just want to get your confidence up, build up your confidence, get motivated, learn stuff, okay?
Okay.
All right, Mike.
Whenever you're
Go
ready.
ahead and read it. Let us know what you think, and then boom.
Score of a string. You are given a string S. The score of a string is defined as the sum of the absolute difference between the ASCII values of adjacent characters. Return the score of S. Okay, example 1. S equals hello. Output is 13. The ASCII values of S are H equals 104, E equals 101, L equals 108, and O equals 111. So the score of S would be 104 minus 101 plus 101 minus 108 plus 108 minus 108 plus 108 minus 11, which is 3 plus 7 plus 0 plus 3 equals 13. Example 2, input S equals ZAZ, output is 50. The values in S are Z equals 122, A equals 97, so the score of S would be 122 minus 97 plus 97 minus 122 equals 25 plus 25 equals 50. Okay. S, there's a constraint on it too, only consists of lowercase letters. Okay.
All right, Mike.
Okay. ASCII values 122.87, 120 plus 27. Okay, we're going back. Okay. Okay. All right. Let's see.
What do you think?
Let's see.
What's the problem asking? What's it about?
So it's taking each letter in the string,
Mm-hmm.
and it's getting its ASCII value,
Yep.
and it's finding the difference between the two ASCII values of the characters. And then it's taking those separately, and then as it has those separate adjacent like differences, it's adding them all together at the end. And that's your
Okay.
score.
How do you know what value it's going to subtract? Like, how do you know what two characters it's going to subtract?
So they're going to be adjacent, so they have to be next to each other.
Perfect.
Yeah.
All right. Well, just thinking out loud, verbally, how would you want to solve this verbally? Like, you don't even need to think about like a code approach, but like, how would you How would you want to solve this? Like a human.
Like a human.
Yeah. Don't overthink it either.
Yeah.
It is a little weird. I mean, I would just like take each of the like 2 characters that are next to each other and then subtract them. Kind of like what it's doing in the example, in the explanation.
Where would you start
Like,
at?
I would start at the beginning of the string,
Okay, and then what? Guide me through.
and then I would subtract H and E,
Okay.
their ASCII values,
Mm-hmm.
and then move over.
Yep.
And then I would subtract E and L, right?
Okay.
Move over and subtract the 2 L's. And I'll move over and I'll subtract the L up. And then in the end, we put them all together.
All right. Now that's how you do it in human way, right?
Yeah.
How would you do that in computer way?
I feel like because like we're sliding like that and we're only on 2 adjacent characters, could we do a sliding window? Is that possible?
It might be.
You-
I don't know.
Window. Sliding window.
Yeah, I mean, technically, yeah.
It might be.
You can think about it like that, yeah.
Or couldn't we just use 2 pointers also, right? And then just increment them?
I would say so.
Yeah, would be similar to sliding window, yeah.
Would you say the goal is to go in pairs of 2 though? Right?
Yeah.
Okay. So yeah, I mean, there's various approaches, and I think I don't want to steer you away from your approach. So by all means, I'm there. I'm supporting you right there. I think you can. No, I mean, there's no right. There's honestly no.
I
No,
feel okay. I
like-
feel like
You can do whatever.
I don't know how to.
as long as you
I
get
don't
the
know how to
problem
code
right.
sliding window. So maybe let's start with 2 pointers first.
Okay.
Because I feel like 2 pointers. We have 2. We have an I. We have a J. You know, it's easy. You know.
Yes.
Okay.
Okay.
And how are you gonna go through the string S? Like how are you gonna glide through it 2 at a time?
Well, we need a for loop, right?
Beautiful. That's a good way to glide.
For I, an N, in S, right? This
Okay.
is gonna be
Okay, you gained somewhere.
traversing-
And Mike,
Traversing the string.
Mike, I just want to say you're doing a great job. Second, it's okay if you don't know the syntax. Just verbally tell us like what you're trying to do, right? And then we could guide you on how to actually write it in the syntax, right? Obviously, you probably don't know, and me and Jose didn't know how to get the ASCII values. So obviously, you shouldn't worry if you don't know it on top of your head. But just like verbally explain how you're gonna do it, and then we could guide you there. Does that make sense? So don't worry about getting syntax all right now. Of course, you would need to get the syntax right in the technical assessment, but just FYI right now, you're okay.
Okay. Before the for loop, we also need somewhere to store the score, right?
Okay.
The sum. So this is gonna be like the sum of the numbers of sum. I'll just put sum for now. And then so we're traversing the string, right? Now we need to get the 2 values of I and N, and then we need to subtract them from each other.
Okay.
So grab values of I and N, and then subtract. Right.
Perfect.
And then we need to subtract, and then the value of I minus N we need to store in score. Right.
Okay. Do you store
So-
it? Okay, sorry. Keep going.
Yeah, that would make sense. Because we're gonna keep adding to score.
Okay. So you need to store and score. Need to add.
Yeah. Or I guess, yeah. So the value of I minus n, we need to add and score. And then we need to increment the I and the n to go to the next
Okay.
increments.
Yeah.
So, increment I and n to go to next adjacent characters.
Okay.
That.
And then
Okay.
We're gonna, and then we're gonna reloop into the for loop. Or like
and then at the
whatever
end,
we do.
once the loop is done, what's next?
Well, we need to. It says we need to return the score of s, right? So we're gonna return score.
Perfect. I think
Right.
it's looking really good.
Return score.
Yeah.
I think that's what it's
Um,
looking like.
Key things, and you would figure. Actually, no. Let's go. Let's get through it then. Okay. So traversing through a string. There's a lot of different ways you could do it in Python. I wonder if you could do this. No, right? You can't do that.
I don't
come
think
on.
so.
No. Okay.
No?
So wait,
Are you sure?
no, but you got verbally. You got. You're right. We want.
Yeah.
To get the first two, or we want to get index 0 and index 1, and then we want to move it to where it's index 1, index 2. Okay? So we want to use the number. We want to say, in that case, we want to say for I in range
Length of s.
of S. That way
And
we
then-
get, that way I is 0 and it goes all the way up to the length of S minus 1.
Yeah. And then the next one would be for j in range.
Do you need
right?
another for loop?
Well, we need the second pointer, no?
You do.
Think about it. Think about the question. You do need a second pointer, but what is that second pointer doing? What's the relationship between the two pointers?
Oh, they're right. They're right next to each other.
Perfect.
So what would you do? You would compare I and I plus 1?
Yeah.
Yeah.
Oh,
Nice.
okay.
Yeah.
Okay. How would you? Okay, so we only need that. So then we just need to do I plus 1, right?
Yeah.
Yeah.
Pretty much. Yeah.
Okay. Okay. So we have that for I in range length s. So that's us traversing through s. Okay. Now we're going to grab the values of I and I plus 1, right?
Mhm.
Then subtract.
Just Carlos, do you want me to give him the function already? That way it's a little bit easier.
Whenever we get there, we could tell him the function. Oh
Okay.
shoot, it's right here. Yeah.
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 It's
My bad, Mike.
ORD ord.
Or-
Yeah, ord. Yeah, ord. Yeah, it's a function. So ord parentheses. That's how you get
Mhm.
the value, the ASCII table of a character. Just a little.
Okay. Hmm.
So whatever you put in ord, it will return back a number, the ASCII value for it.
Okay.
But think about it. Enter index. What does that mean?
Ord. Well, we need the index of where I is at, right?
Yeah.
You need the L. Never mind.
Whoa. Let him think about it. Let him think about it.
Ord. I'm blanking. I'm
No,
forgetting
you're
how to
okay. You're
type
Come on,
okay.
bro.
You're okay.
Come
you're
on,
okay.
brother.
values.
You're here.
I'm
Come on,
forgetting how to
brother.
obtain values.
Think of a
Mike,
string as an array.
Mike, what do you want to
Think
put
of
in ord right now? Don't think of
Well, we
don't
need-
think of code right now. What do you want to put in ord?
We need to get whatever I is on, like whatever value I is on.
Okay.
Yeah.
And then we need to subtract that with I plus 1.
All right. I mean, I
Yes.
think you said it right. You just probably don't know how to do the syntax, and that's okay. It would be this.
S of I. Okay, yeah, because that's the string.
Yeah.
And then
Yeah.
whatever we're on.
Think of like strings as like arrays when you're trying to access like different characters in it, or
Mhm.
even traverse.
And now we need to get I plus 1 and subtract it, right?
Yeah.
So S of I plus
Whoa,
1.
whoa, 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 whoa! Look at where you're doing the minus plus, the subtraction. What are we trying to subtract?
The next value.
Yeah.
So,
So
Mike,
But
just
but
for an example,
look at
you go, Jose. You want to go?
but like you're trying to subtract what two variables, what two things. Look at the question back and look what are you subtracting? Because ord just gets one character and spits out the ASCII value.
Oh, okay, it only does 1.
Yeah.
Okay. Well, we're trying to get the adjacent characters. Or
Yeah,
difference
okay,
between
yeah.
the ASCII values. So we'd
Yeah.
have to do minus ord again. Or
Yeah.
minus ord.
Yeah.
Yeah.
There you go.
S of I plus 1.
Brilliant.
Okay.
Now this
Okay.
this will spit out what, Mike?
That'll print out the ASCII of S of I minus the ASCII of S of I plus 1.
Okay.
So if we're working with hello, it'll do 104 minus 101.
And what does
Yeah.
that equal?
3.
Or like in an equation sense, like you gotta equal it to something.
Oh, this is gonna be. Is this gonna be score?
I mean, you can name it whatever you want.
That could work.
You can name it whatever you want.
Yeah.
Well, cause like score is up here.
Is it though?
Oh,
Mm,
well, in his comments it is. If
Well, in his
score
comments it is.
If score is what you wanna call it, then no, score can't be in here, unless.
Yeah, score it.
so this is gonna be different. This is gonna be different than from our like actual
Actually,
sum.
you know what? I think you're Mike. You're right. I think you can keep score in here, but of
What
course.
about if I did like this?
Yeah, I think that works.
The only
And
thing
then-
I would say, yeah, there we go. Okay, yeah,
And then we increment it right here, or adding it to score.
but why
Yes.
an array? Why an array on line 4?
I don't know.
Look at our output on example 1 and 2.
It's just a number.
Yeah,
Okay.
yeah. So why? So you put score as an
Like-
array?
Yeah, we don't need an array then.
I don't know.
What's the base? The base everyone starts at. If I'm counting.
0.
Okay,
Come
nice.
on, Maro.
Come on, Mike. Come
What are
on,
you
Mike.
doing?
Come
What are
on.
you
Come
doing?
on, Mike. Come
Okay,
on.
okay,
Alright.
okay. Yeah, we're back. We're back.
You got this, though. You got this. You got this.
We're back.
Okay.
The score equals 0. Right. Score plus equals the sum of these two, which shall be 3. So now score is now 3 after this, right?
Mhm.
Of hello.
Yeah, you're doing good. You do everything up to right now is good, except
Oh, there's a big except. Yeah.
except one thing.
Oh,
One thing.
A big thing,
Except
but you
one
got
thing.
it, Mike. It's an easy fix.
You got it, Mike.
I would
It has
say.
to do with
Oh,
You
what
go,
were
you
gonna
go,
say?
you go,
What were you gonna
Carlos.
say?
You go, Carlos.
Maybe we're
No,
thinking
that
of two
was
different
gonna-
things, but obviously there's
Yeah,
a
that's
big
right.
mistake.
You go, you go.
Okay, Mike,
Hmm.
read the problem again. It wants a score of a
Oh,
string.
there's
is...
two. There's
Okay,
two.
there's two
problems.
things. There's two.
There's
things.
two. There's
There's
two.
Okay, see,
Let
I...
him finish. Let him
Okay.
finish. We'll figure it out. We'll figure it. Let him finish. Come on, Mike.
All right, Mike. Let's cross things off the list, Mike. Okay,
A
the value of
score of
I
a
minus
string.
n. The value
Score
of
of
I
a
minus...
string.
The value of I minus n, Mike. We need to add in score. Have you done this already?
Yeah, we did that.
All right, boom. Cross it out. This one. Are you incrementing I and n to go to the next adjacent characters?
Not yet, not yet, not yet.
Ooh.
Ooh.
Okay, okay,
Now-
okay. We'll let you.
now,
We'll
the
let you
only
go.
thing
We'll
is
let you go.
now
We'll let
it's-
you go.
Now it's this though.
Okay, okay.
That
okay.
is true though. How are we gonna move it?
Well,
Come on, Mike.
Mike. Let's look.
How are we gonna move it?
Come on, Mike. Look at line 6. Look at line 6.
Look at line 6. Okay.
What does that 4 do? What is line 6 doing?
Traversing through the entire thing.
Yes.
Yeah.
Okay.
If it's traversing to the entire thing with I, what is I doing? What is line 6 doing for you to I?
It's incrementing it already.
Yeah.
Brilliant. Good stuff.
Okay.
So would you say
So
this
you don't
is
have
already
to
done?
increment anything.
I guess so.
It's a
That's
for
kind
loop.
of confusing. That's kind of confusing. Yes.
Okay, what are you
It's a
confused
for
on,
loop
Mike?
because-
Tell
yeah.
us. Tell us.
How is it? Okay, but like if we wrap back around,
What do you
right?
mean wrap back?
Like how is it gonna know to do E and L next, not H and E again?
Well, because
look
I,
at,
if it starts at 0, right? Like if you look over here, this is
Mhm.
0. And you're saying, in this logic, you're saying that S of I, S of 0 is H. Get the ASCII key of H. Minus,
Mhm.
get the ASCII key of I plus 1, which I is 0. So this is going to be 1. So S of 1, where's that at? That's E. Okay?
Mm-hmm.
If you, now this loop is done. It does this, now it's done. Or
Okay,
that
yeah.
iteration's done. Now you're at 1. I is 1 now.
Okay, and then S.
And so then
I
S
one,
is,
one is 2.
yeah, and then
Okay.
this is 2, and
Okay,
then
okay,
yes. That's it.
Okay, cool.
Does that make sense?
That's done. Yep.
That's
Okay.
done.
Okay, now
Okay.
I think there's still 2 things. I think I know Jose's
Oh,
mentioned.
yeah.
Or he's good.
Yeah.
Or he'll find out. He'll
no,
find out.
He'll find
Okay.
out. He's still
Let's-
missing 2
let's-
things. He's still
next-
missing 2 things.
Return the score.
Okay.
Okay.
All right. Let's
Alright,
run.
okay.
Don't click submit, Mike. This is our prized possession. This is our
Bang!
account. This is hardworking
Just kidding.
geniuses account. If you click
It
submit,
runs on.
No,
runs on his
runs
account.
mine, it runs on
Oh,
mine.
Yeah,
okay,
it runs
okay.
on his account.
Well-
We're just gonna see if you got it
Dang.
right or wrong.
Okay, Mike. Just at least
Runtime error.
you got a runtime error. Okay.
Good,
You
good,
click
good,
run.
good.
You
Okay.
click run.
Yeah, I clicked run. We got
Okay.
runtime error.
So this is the error you got, right?
It. Okay. What
Okay.
what is the error saying right here, Mike? And where?
Index
Why? Yeah. Why
out
do
of
you think it's
range.
happening?
Because when we get to the end of the string,
Mm-hmm.
I is trying to go after the string,
Yeah.
right? Because of this.
Yeah.
Okay.
How would
Beautiful.
you solve that?
I don't know. I don't know how to fix that.
Come on, Mike. Come on, Mike.
Would we need like some sort of like if statement on it or no?
If that works.
Like if. Oh man, I don't know.
Come on, Mike. Think about it. Think about it. Think about it.
So the end of the string would
End of the
be
string.
I minus 1, right?
What if we can avoid hitting the end of the string?
How would you do that?
What about we modify?
Mike, in a for loop, you determine its conditions. You determine when it stops.
When it stops, yeah.
For
Or you can
loop,
do another if statement if that's easier for you.
for loop.
Oh, for I in range length of S minus 1. No?
Yeah,
Woo!
yeah,
Look at you.
What? Why
The
would
wheels
you
are
put
turning.
right here? Is it right here?
yeah,
That.
yeah.
That
All
way
right.
it's saying, hey,
Hey,
stop
what?
at the end of the string. That's what it's saying.
Yeah. Yeah.
Okay. Run
Pretty
it.
much.
Running it.
Bang! Ufas.
Move
Wrong
fast.
answer,
Alright,
move
let's
fast.
read. This is the problem Carlos was talking about. Let's read the problem. I'm gonna let you take this
All
one,
right,
Carlos.
reread the problem again, Mike. Not the examples. Or, I mean, you can look at the examples too, but reread it again. Okay.
I think the examples can give it a little bit more.
Yeah, you could definitely see
A
it in
little
the
bit more.
examples, but it's right there in the words.
You're given a string S. The score of a string is defined as the sum of the absolute difference between the ASCII values of adjacent characters. The absolute difference.
What does absolute difference mean?
That's a good word, right, Jose?
Well,
Absolute,
like
yeah.
absolute is like if it's like a negative. The absolute of a -7 would be a +7, right? Something like that.
Yeah. Yeah.
Right.
I like that thinking.
ABS. That's
No,
cool.
what are you trying to do? Because I don't know if you might know the function. What are you trying to do, Mike?
I need to get the absolute difference, but one, I don't know where it goes, and two, I don't know what the function is.
Okay, so the function is
Okay.
the function is ABS parentheses. Parentheses, and inside the parentheses you put the value you want the absolute value of. Yeah or nay?
If I did it to the beginning, would that work for the rest of the time or no?
Well,
Like this?
think about it.
Look at the examples now, Mike.
Look at the examples. Look at the examples now.
Okay. Okay.
Where's it get?
Look
When is
at-
it getting the absolute value?
Look
Right
at the
here,
104
108.
minus
108 minus 111. 101 minus 108.
101.
Okay, so it's getting it at the calculation. So it needs to be. It needs to be after we're done calculating it, right? Because it. Okay. Okay. So would it be like this, like ABS, like this?
Maybe run it. Maybe run it. Maybe run it.
Let's go.
Let's go,
go.
Mike. Let's
Oof.
go, Mike.
Wait a minute. You're onto something, Mike.
I haven't submitted it yet, though. I don't know.
You want to look at the
Hey,
hints?
Should I?
No.
Hint one.
Any test cases you want to look at?
Oofus, bro. Maybe.
Let's
I
stop
don't know.
wasting time. I think you should submit it.
Okay,
Bad.
bang.
Did you get it, Mike?
Yeah,
Nice. Let's go. Get it.
Let's
Yay for
go.
Mike. Yay for Mike. Celebration.
Yay for Mike. Yay for
Oh.
Mike.
Mike.
We solved a
Proud of you,
problem.
man.
Another one. Another.
Yeah. How do you feel with this problem? How was this problem for you, Mike? Was it hard? Was it confusing?
It wasn't too bad. I think just the whole the ordinance thing.
Okay.
But like. Oh well, yeah. Like obviously I didn't know how to do the ASCII thing, but now I do the ordinance thing.
Yeah.
But it wasn't bad. I think it was a pretty simple, like traversing, and then comparing and then updating. Like.
Okay.
Uh,
So it's just more like how to implement it, pretty much. Like
Yeah,
you
yeah,
understood the problem, you understood an idea of how to solve it, but it's just like knowing the implementation, knowing like a little bit here and there to
Yeah.
like bring it back to that. But like you do understand the approach on how
Yeah.
to do it. Okay.
Yeah,
Perfect.
yeah. I think what Carlos said helped a lot. Like try to solve it as a human first.
Yeah, for sure.
Thank you, Mike. I appreciate
That was good, bro. That was good because I was already thinking like how I would approach it to program it, but I was kind of lost still. And then you were like, "Hey, bro, solve it as a human." And then when you said that, I don't remember what clicked, but something would click. I was like, "Oh, okay, that's how you do that."
All right. Well, you better start clicking again because I got another problem for you.
Ooh, we got 8 minutes on the clock though.
8 minutes on the clock.
Everyone.
It doesn't matter,
Bang.
Mike.
Dang.
This is everyone. we have 8 minutes left. We're gonna give it up for Mike to solve this problem. It is called concatenation of array. Mike, go ahead and read it. Don't read everything. We're speedrunning this thing, okay?
Send me the link again.
Oh.
Link me, bro. Go ahead and link me, bro.
Send the link.
You don't do it right, okay?
I need a Max Win.
Yeah, I don't need it.
No, I said you don't do it right.
Yeah,
This is still
Damn,
score.
bro.
Wait, hang on.
Come on, Mike.
Let me fully.
Lock in, Mike.
Let me fully.
Come on, Mike.
It's not. It did score of a string again.
Oh, okay. Here you go.
Okay, it was the wrong one.
Sorry.
Damn, Carlos can't do it right.
all right, here it goes. Speedrun,
Okay.
bang.
All right, Mike. Just read
Given
the
an
problem.
integer concatenation of an array. Given an integer array nums of length n, you want to create an array answer of length 2n, where answer of I equals nums of I, and answer of I plus n equals nums of I. For 0 to n. Specifically, answer is a concatenation of two nums arrays. Return the array answer. Nums 1.
I don't even remember doing this one.
It's kind of confusing. I can't lie. Let's do it. Let's go.
I see.
Don't
Okay.
overthink it. Again, think like a human. What is it? What's the problem asking for?
I see.
You want to create an array answer of length 2n.
Mhm.
So whatever our nums array is, we're doubling it.
Nice. Do you think so?
Okay. It looks like it. Based on the
Perfect.
examples, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2. Yeah.
All right.
So, we have an array of nums. So basically, we have an array.
So what do you want to do to the array again?
We need to double the array
Perfect.
of nums, right? So
Yeah, that sounds good to me.
nums will be doubled into answer, basically. And then we just need to return it, right?
Yeah.
Okay. We need a for loop.
I think Carlos. I think Mike. I think. Oh, well, there's a. I think Mike got it, Carlos. I think we can let him. Let him do this one and
Alright,
help him
Mike.
out whenever he's like really stuck. We can go in there.
Okay. You heard that, Mike? Boss
Yep.
number 2 just told me I can't help you out here. Sorry. Man. But make
Okay,
sure you talk it
answer
out.
is an empty array. Answer is an empty array because it's empty right now. There's nothing in it. Okay. Bang! Right. For now we need a for loop. Do we need a for loop? Get an array nums of length n. For I'm blanking.
Okay.
It's
What are you trying to do? Just write it out in comments. What are you trying to do, man?
I'm just trying to get the for loop started.
Okay.
It's length n. So it needs to be
What do you need a for loop for? What are you trying to do for a for loop?
we need to traverse through nums and then double it. Wait, why don't we just double nums? Wait, we can use a. Can we use a dictionary on this?
You can do whatever you think is gonna solve the problem.
Oh, fast, bro.
But why would you use a dictionary?
There.
What do you usually?
Because
use a dictionary for?
it's grabbing the index and the value. But I guess we don't really need the index. We just need the value, right? And double it.
How about this, Mike? Ready? Let me explain it to you. You physically have in front of you. You have.
Look at the examples. Look at the examples. Look at the
No,
examples.
he understands the problem, Jose. It's just that he doesn't
Oh.
understand how to do it. But I was trying to give him an impromptu physical example, but I blanked out. Okay, or it didn't make sense in the head. Mike, you ready? You already have a list of nums.
Yes.
Let's say there's some way you duplicate that list and you add them together. By add them, I mean you add it to the end of the first list.
Okay. Okay.
Mm.
We're
'Cause-
concatenating arrays.
Concatenation of array. Yes, that's what we're doing here.
Holy. Okay.
So how?
So we don't need a.
I think you can do it in one line, Mike.
One line.
Yes, he can do it in one line, but in because Python makes it easy. But imagine this wasn't Python. Imagine this was C, right? Like
Okay.
you would have to do something. You would have to make a copy and then add that copy to the end.
Okay. Okay. Well, couldn't copy be my? No. Okay, so we have answer as an empty array, right? What about? Do we make copy as an empty array too?
That looks. I mean, right?
work?
Yeah. I mean.
And then we could copy equals. Is that right? No, copy equals nums, right?
Yeah. I mean. Yeah.
Okay. Hang.
Holding.
And then we do answer. Can you just add two arrays together like that, like plus? Because what I was thinking, we would use a append. But
Okay. You
I don't know if
can
that
do a
would
pen. Okay.
No.
Append. Yeah, I don't think you can.
Append adds an element to a list. Right here, you're
Yeah.
not trying to add an element to a list. You're trying to combine the list together.
Would that
Okay.
work?
That could work, yeah.
Return ends.
Bang!
What did it say?
It accepts it.
Yes, sir.
Nice.
It's that, bro. There's no way. Can I submit this and it'll work?
I don't know. Go ahead. You do it first, though.
Ooh, fast. Okay, let's see. Wow, it does. What the heck? Why does that
Nice,
work?
Mike. So, Mike,
That's so simple.
pretty easy, right, Mike?
Yeah.
Not,
pretty
not
easy.
really a trick here, but it's just because Python's really good at like doing stuff for you. But I wanted just to dive deep a little bit, or I don't know if it's that deep, but basically, in like C, I believe you would have to loop through nums, right? So the approach would be you have like what you just did. You have a copy, you have an empty list, right?
Mm-hmm.
You want to loop through nums and append and populate copy that
Yes.
populate copy with what nums has. So for element
I and nums.
in nums, right? You can do I, yeah. For I and nums, you do copy dot append I. Now that copy is literally a copy of nums. Now you gotta add the two. And what you would do is you would append it. I guess you would append it to nums. But I think there's even a better way to do that. But for this approach, you're making a copy array, and then you append those elements in the copy array to the answer or to the nums array. Am I making sense?
Okay. Yeah,
But there's
like-
definitely
like,
a better
what-
approach. But that's just like one
But like,
that I could
why
say.
wouldn't you, once you get that for loop done and it's a full copy, wouldn't you just answer equals copy plus nums again? Like, wouldn't that be a thing? Or no?
Yes.
Uh,
But
yeah.
you can do that. But I was thinking like in C, how would you do it? And C, you can't just say like copy plus
Oh, okay.
nums or because you gotta like add them together. I don't think you can. I don't think you could do that.
I don't think you can. Yeah.
No, no, I see what you're saying. I see what you're saying. You're just trying to find like the.
So what you would do, and this
other
might be redundant, you would loop in copy. So for I in copy, you're gonna say nums dot append I. So now nums is doubled, and you return nums. I'm pretty sure that like doubles it. Does that make sense? Like you made a copy,
Yeah.
and you
I
loop through that
copy.
copy just to append it to nums.
Yeah.
So
So,
you
now,
could
so now we
say-
have our copy, and now since we have our copy, now we're just appending copy back to nums,
Yes.
and then we're returning nums.
Mhm.
That makes sense.
Yeah. And again, for the folks watching, there's probably a better way to do it all in one for loop, like if you're doing it in C. But I guess that's just what I thought to explain to Mike. So, does that make sense, Mike?
Yes, sir.
Yeah.
That makes sense. That
So,
makes sense. Yeah,
well,
yeah,
of course-
that's what I was thinking at first, was like looping through the array and then like making the copy and then appending it. But I was getting confused. But yeah.
yeah. All right.
Damn, bro.
Well, let's hit a yay.
Tap it
Hit a
up.
yay for Michael. Michael, it takes a lot of courage to come on a stream and to do something that maybe you
Out
don't
of this
feel,
big audience.
yeah, in front of
Big
this
audience.
big audience, and do something maybe you're not as comfortable doing, right? Like that's very admirable. So I appreciate you for coming on today.
Thank you guys. Thank y'all for having me. Thank you for coaching me.
Hey,
Before
that's
you
what
go,
you're here for, brother.
before you go, let's do a little conclusion. Mike, what were your top moments in the stream? What were the top things you learned? Top things you'll take with you? Oh wait,
Feedback
Jose's
on
raising his
us.
hand. Feedback on us, yes.
Like a-
How can we be better? How can we coach you better? Maybe we do another stream where we coach you again. What do you think, man? What was your favorite part? Anyways, I said so many questions. Just say whatever you want.
Okay. I think overall it's pretty good. Pretty good overall. Maybe like a little bit more like explanation on like why things wouldn't work.
Ooh.
But I mean, like overall, it was pretty good. You guys kind of like led me to the right path and in like the identifying stuff and also the coding, so that's pretty good. And then some key things I took away: the binary search identification. I'll take away that. I'll learn more of that, and then also the sliding window. I think that's like kind of, now that I kind of know when to use those and how to like look at when to use those, I feel pretty good on those. But yeah, overall, good coaching, boys. Good coaching. Thank you.
Thank you, Mike.
Yeah.
Oh, thank you
Hey,
for
that's
being
what
a,
we're here for.
Thank you for being a good student, Mike.
Thank you, bro. Thank you.
You
Hopefully,
get a little star.
Thank you. Hey, well, hopefully I'll be back on the stream and I'll be an employed engineer. It'd be great. It'd be a good time. And then I'll be like, thanks guys. Thanks for my coaches.
Yeah, no problem.
Well, yeah. I wish you the best, Mike.
Sorry, I
you
was
know,
reading
you got
chat.
it in you.
Mike,
You got it.
now let me give you feedback for you.
Okay.
All right, feedback for you is think more out loud, man. Start thinking like first as a human. How would you solve it as a human first? Break it down, right? Again, whenever you're gonna do more LeetCode problems in the future, you might not know the syntax and everything right away. Feel free to Google like how do you get the ASCII value of a character, right? So don't hesitate to Google. The thing is, I will say is hesitate on is don't Google the answer. Like, you know, work through it. Look at notes or whatever you have to, and then good feedback though. I think you did great understanding, right? You did great asking questions. You did great, like,
Thank you.
whenever you were stuck, you express why you were stuck, right? That's always good. Clarity, right? But whenever you have a problem, it's good to explain that problem really well to someone so they could best help you. So I think that was great.
Yep. All right. Well,
Jose doesn't want to say anything.
Yes, sir. Hello? You hear me?
Yeah, we hear you.
Oh, okay. I thought my mic was muted. No, man. I think you got it in you. I think you know concepts. And I think, you got, like Carlos said it, I think it's just more like syntax wise. So when it comes to syntax, you can probably just like, do some Googling on stuff. That way you can figure it out. But as long as you have a solution in mind, an approach to do, like how to solve it, the tools to use, and the concepts that you're gonna use to solve the problem, you should be good. You should be good.
Well, sounds good, boys.
All right, Mike.
Good
Thank you
stream.
for coming on. Appreciate you. Good luck. Good luck,
Yes, sir.
Roland. You have the
Yeah, brother.
confidence. You have our support. Whatever you need, we got you.
Yes, sir.
So,
We got you, man. We got you.
all right, Mike.
Thank you.
We'll
Thank
catch you
Catch
around.
y'all later.
Stream. Thank you for joining tonight. We'll be here again next week for a coding stream, and then look out for possibly some short videos. Right, Jose?
Yeah.
Possibly some
Oh,
short
100%.
videos. No,
100%.
Don't say 100%, Jose. Don't say 100%. 99, 99%.
99.99, like the
There's
king
always a
supplies.
chance. There's always a chance. All right, everyone. Have a good night. We'll see y'all next week.
Alright.
Later, guys.
Bye bye, guys. Take care.